This question asks us to follow the mean value theorem for this function to find when the instantaneous rate of change will equal the average rate of change. We know that when we say instantaneous rate of change, that means the derivative. So when is the derivative, f prime of c at some point c, going to be the same as the average rate of change? Average rate of change is always that f of b minus f of a over b minus a, where a and b are the start and end points of our interval. So let's find that average rate of change first. We want f of 2 minus f of 0 over 2 minus 0. What will that equal? It's going to be 2 cubed minus 2 times 2 squared minus 3 minus 0 cubed minus 2 times 0 squared minus 3 all over 2 minus 0, which is 2. 2 cubed is 8. 2 times 2 squared is the same as 2 cubed, so 8 minus 3 minus 0 minus 0 minus 3 over 2. This will give us negative 3 plus 3 over 2, which will be 0, because negative 3 plus 3 is 0. 0 over anything is 0. So we find the average rate of change is 0. Now it's asking us, when is the average rate of change equal to the instantaneous rate of change? So we want to say the instantaneous rate of change is the derivative. So let's find y prime. I'll use blue for this. Y prime equals, well, I'm just going to apply the power rule, 3x squared minus 4x minus 0, because the derivative constant is 0. So we're left here. And when is this equal to that? We have to write an equation. Use green. 0 equals 3x squared minus 4x. I know that I can factor out an x from each of these terms, and so I'm going to do that. 0 equals 3, oh, not 3, sorry. I said I was going to factor out an x. X times 3x minus 4. By the zero product property, I know that x has to equal 0, or 3x minus 4 has to equal 0, because both these things multiply to make 0. One of them has to be 0. We already have one of them. I'm going to add 4 to both sides, divide by 3, so I get x equals 4 over 3. And so, by the mean value theorem, we see that the two locations on this interval from 0 to 2, where this is true, is 0 and 4 over 3.